Good morning, sir. This is Team 7, and in today's video, we'll be explaining our entire project and how we prepared this over the course of time. So, our project is based on smart security systems, where we are designing a warehouse which will government or private warehouses where there will be a couple of security measures taken before a person can enter or before an authorized person can enter the premises. So, in this video, I'll be explaining you how we have achieved this. And starting with my introduction, I'm Navneet Amrit, roll number 101806140, and uh, I'm mostly in charge of the OpenCV and Python part of the programming part of the team. And I'll introduce you to my team members after this, and I'll be taking you through the entire process. My team members, starting from Nitin Kulhari.
Hi, this is Nitin Kulhari, 101806199. My input or my contribution towards the group was a part of the image processing. Image processing is a technique to enhance raw images received from cameras, sensors, which is used to detect facial recognition, and for which I used OpenCV library. What is OpenCV library? OpenCV is a free open source library used in real-time processing. It is also used to process images, videos, and even nice.
Hi, this is Siddharth Suhag, roll number 101806197. My contribution in our project on smart security system involved the system initialization and configuration. This involved the following tasks: importing Python libraries and packages. These libraries are predefined and help in making the interfaced modules work properly. I also worked on the PyCamera settings and configurations, the GPIO settings and pin initialization. The channel was set using the BCM channel numbering, and passive infrared pin channel was set to read mode while the LED channel was set to drive write mode. Thank you.
Hello sir, I am Nachiketa. My major role in this project was to develop and write all necessary code to operate Raspberry Pi and write image processing code using OpenCV library and install Raspberry Pi operating system required in this project. And I use Python library SMTP live for sending an email to user. That is all from my side. Thank you, sir.
Hi, this is Pahwa, 101806196, and my contribution to the project was more towards the hardware side, where I worked with the Raspberry Pi and other different sensors. And as we know, Raspberry Pi can be used to implement security system with motion detection, image processing, and alert mechanism, as it is one of the critical part of this project.
Yes, so this is the final project. As you can see here, this is the house which we have made. This is made of cardboard, and now we'll be showing you an entire demonstration. This is the Pi camera, and above that is the LED light which we have attached for better facial recognition, because we are using eyes and faces rather than Fisher faces algorithm. So I'll remove the top of the house, and you can just take a peek look inside and what the system is. So here we have attached a Raspberry Pi, as you can see, and here is a switch to toggle the LED light on and off manually. So that can also be done by the computer itself. So apart from that, you can see this is attached to a charger, and the charger is this wire is attached to my Nokia charger outside. So this is a 12-volt charger, 2 amperes, which is used to charge, which is connected through a SSIH, so that we can connect it through to the Python to the Raspberry Pi, as well as to our LED. So apart from that, you can see this is all the other components, the other sensors attached. Here is the servo motor attached, so it will keep the door locked, and as soon as it detects the right person in front of it, the servo motor will automatically move and the door will open. So let's close the cap and start the process. So the flashlight is on, and I've switched it on manually, and this is the SSIH cable which I've attached to my laptop, and now I'll be running the Python code on the screen. So as you can see, we have loaded, till now we have loaded 10 images, and but the file can load 40 images. So loading 40 images, 441 negative images and 40 positive images. So that is a huge, that will be very huge, because the data size will come out to be somewhere around 8 GB. So it will take a lot of time if we put entire data set right now. So we have just made a training data set. So first we'll be trying to initialize our training data set. So we're loading our training data set, as you can see here, and it will take a moment. So there's a training data set. Okay, so this is again connected with our Raspberry Pi camera, and this camera will detect the face of the person in front of it. So here you can see, I apologize for my camera, the camera quality is not that good. Yes, so our data set is already loaded in the entire file. Images scanned. So now we'll be continuing with the channel has been initiated and the channel initially set to 0, so the door is locked, as you can see. So when the channel will be set to 1, the door will unlock automatically. And yes, so this is the switch which will be used to lock the door again. As soon as the door gets unlocked, we'll use the switch to lock the door again. And this is so we have initialized the process, and right now we'll go for the facial detection part. So as you can see, this camera is detecting, we have locked the door, and this camera is now detecting my face. And as soon as it detects my face, it will show that face has been recognized and the door will open. So you can see the door has opened, the servo motors has moved behind, the door has opened. So now if you want to lock the door again, you can just use the switch given outside. So as soon as you click it, the door will get locked again. See? Yes. Thank you. And as you can see, this is the user case diagram, the general flowchart and for detection model. And this is the flowchart for the detection in security implementation. And as you can see, this is how we have set up the entire architecture of our system. Signing off, Team 7, Capstone. Thank you for your time.